horseshoe, and in the back around, like a horseshoe. So, we're gonna put our 0 here, we're gonna go behind this one, behind this one, behind this one, and over to here, and I get 23. What's half of 23? 11.5. I dropped my pencil again. 11.5. I have this one done. I'm going to look and it goes right with that one and this one. That's a good thing, right? What's half of 11 and a half? 5.75. 5.75, and it goes with this one. And this measurement is done. Oh, I didn't cross this one. 5.75. Do you see those measurements? One more set of measurements in the back. Anterior horseshoe, posterior horseshoe. Okay? Put the 0 here, go behind this one. I get 24. What's half of 24?
12.
Does this look like it goes with that one?
Yep.
Okay, so what's half of 12? If I cross this one, does it look like it goes in line with that one and that one? I can go with 6, 12. What's this one going to be?
18.
18. That math is easy, isn't it? minutes.
16 and 55.
16 minutes and 55 seconds. Pretty good, huh? Except I dropped my pencil, dropped my tape measure.
You had to stop to explain, so
Okay.
she's a lot quicker than 16 minutes.
I could probably do a whole head in 16 minutes if I had to. That's with putting electrodes on too. If it was stat in the ICU on a patient that's seizing, you get pretty darn quick at it. But you only get quick at it if you use this methodology. If you keep doing the same thing the same way over and over and over and over, you get good at it. You memorize it. You build little brain maps, right? You're mapping this out. It takes eye-hand coordination. It takes finger dexterity. It doesn't come overnight. So now when I say I want to find out if these electrodes are symmetrical, what's this electrode here on the left side of the head? FP1. The homologous electrode on the right side of the head is what? FP2. What's this electrode here? F3. And the homologous electrode is what? F4. What's this electrode here? On the left, so it's what? C3. The homologous electrode on the right is what? C4. What's this electrode here from the parietal lobe on the left? And the homologous electrode? C4. Now we're in the occipital lobe in the back on the left. What's that one? O1. What's the homologous electrode on the right? O2. So the distance between these measurements should be equal from side to side. And if we were to link these electrodes together in chains, the chain on the left should match the chain on the right. The chain here should match the chain here, right? If I were to measure all the distances between each of these around the circumference, they should all be equal, right? That's what you're documenting on this 1020 measurement documentation. You're going to mark any deviances that you might have. We need to have our electrodes 5 millimeters or less in deviance. So if I measure from FP1 to F3, I get 6.6. So now I'm going to measure FP2 to F4, and what do I get? I get 6.6. Is there a deviance? Can you have 1 millimeter difference? Can you have 2 millimeter difference, 3 millimeter difference, 4 millimeter difference, 5 millimeter difference? Up to 5. Okay? Same thing if you measured F3 to C3 and you get 7, F4 to C4, and you get 7.1. Is that deviance okay? Okay, does that make sense? I don't want to take the time to measure each deviance and document it, but you'll have time to do it in lab. You can print as many of these sheets as you want. You can measure the head, then check your measurements and document them, and look and see if you have any problem areas. You can maybe mark it on this little head diagram. Any questions?
If you encounter someone with a deformity or a head irregularity,
So you need to accommodate that. Someone has a skull fracture, someone has a big hematoma, someone has an intraventricular shunt into their lateral ventricles. It's going to look different on one side to the other, and you adjust your measurements accordingly. If you move an electrode, say they have a big open skull fracture and you can see underneath their skin here. You're not going to measure and put an electrode there, are you? You're going to move it. If you move it laterally to avoid it, you're going to move this one laterally. Make sense? If you've got something here, if you move it medially or towards the midline, you're going to move this one medially, the equal amount. Make sense? Then you document it on your head diagram. That's one of the things you should document on every patient. If they have any skull defects or deformities with electrode deviations or measurement deviations. I think Courtney was first.
So if you're moving, like let's say you're moving F4 and then you move F3 just a little bit as well, do you now readjust every, like,
Nope, you just move
just
those
those two?
off.
Okay.
Who was the next question? I don't know. Aaron?
Is there any case where you would deviate from symmetry? Or is symmetry sort of the golden rule?
That's the golden rule.
Okay.
You might add an extra electrode. If someone has an abnormality that you're seeing, you might add an electrode in to map out that abnormality. So you might add electrodes.
If you're doing that, do you always have to add like?
You
another
don't on the
cross
other
references?
side.
No?
You don't. Well, unless there are some instances, which is called, I can't think of what that's called right now. But for the most part, you would map out the abnormality unless there was a horizontal dipole on the other side of the brain. Then you would. Where there's a negative pole here, positive here of abnormality. Sometimes that's seen in the temporal lobes. You probably wouldn't do it in PSG unless you're doing research. Question?
So like, what would you do, for instance, like if somebody had a cochlear implant, would you, so you just?
That would be behind the ear,
Yeah.
usually back here. You wouldn't put an electrode on the mastoid then. You could maybe move it up and move this one up and document. You could use the lobe.
so in terms of proper documentation, we could just make a note, cochlear implant.
Whatever it
shifted-
is.
Shifted this up.
How
5
many
centimeters,
millimeters?
how many-
5 millimeters? The least amount of millimeters you need to move it to not get in that sterile field if there's, there might be something, if there's an intraventricular shunt because they have hydrocephalus or something and their lateral ventricles need to be drained and monitored. They're going to have an actual shunt right into their ventricle with a monitor here, and they're going to have that on the head, and they're going to have what we call tegaderm, this really sticky stuff over the top. You're not going to be able to put an electrode there. You might have to deviate a few electrodes, and then you deviate the other ones, and then you draw it and document it. You don't see it real often in PSGs. You see it quite often in EMGs. But good questions. Any other questions? So, how many chairs we got? Let's see. Brandy, you can sit back there on the chair.